let's start. We got a few minutes. I'll just start the next thing because it actually ties into what the election auditing stuff I was talking about earlier today. All right. An awful lot of statistics has to do with estimating properties of populations from random samples. So we get some data that are not a complete census. They're a sample instead of a census, and we're trying to learn something about the population based on the sample. And there's an awful lot of technology, theory, experience that tells us how good a job you can do of estimating what's true for a larger group based on a sample from it. And everything rides on how you draw the sample and what you do with the sample. So parameters are properties of the larger group. Okay? Statistics are things you compute from a sample. So, for example, we could the average weight of people in this room is a parameter, right? It's some number that we could compute if we knew everybody's weight. We could estimate the average weight of people in the room by taking a random sample of 5 people and averaging their weights. That would be a statistic. The sample mean of the weights of 5 people drawn at random is a statistic. The parameter is the average weight of everybody in the class. Okay, everybody in the room right now. Okay, so typically we are calculating statistics in order to estimate a population parameter. And what's going on with the election auditing that I'm doing is I'm taking a random sample of ballots and finding the error in that random sample of ballots, the error in how they were counted. So that's a statistic. And what I'm trying to draw a conclusion about is how much error was there in all in counting all the ballots. And if I can conclude based on the random sample that the total error in counting all the ballots didn't amount to the margin, it was less than the margin of victory, then I can conclude that the apparent winner is the true winner. But if the amount of error in the whole contest could have been bigger than the margin, the margin might be an error, right? The real situation might be the winners were in a different order, so that a different person won, different candidate won, and error caused the wrong person to appear to win. So I'm trying to draw an inference about a population parameter, how much error there was in counting the votes in all, based on a random sample, how much error there was in counting the votes in some random sample of precincts. Does this make sense? Okay. So just think about some numbers. We're coming up on another census year, which is always exciting, if that's your kind of thing. Okay, so the number of black males aged 30 to 44 in a given block in the census, is that a parameter or a statistic? Statistic, parameter, a shrug, it's a shrug. It's a parameter, right? It's some property of the whole population, and the census is going to try to estimate that. It's going to go out and look for people in the block, and the number it finds is not going to be exactly equal to the number who actually reside there, right? So this is a statistic. It's not based on a random sample, but it's still a statistic. It's coming from some sample. Okay. Why on earth would you want to sample? Why do I want to sample in doing election auditing? What's the alternative to sampling? Counting all of it, right? So do I really want to go count 180,000 votes in Marin County in order to figure out what happened? No. I'd like to count some much smaller number and extrapolate from that in order to do things efficiently.